Hey guys, this is section 3 of chapter 1. It's covering measuring segments. Now as you can see, we have 4 objectives here. Our first one is to measure segment lengths. So we're going to do that by lining up these segments to number lines and measuring them that way. The second objective is I can use a segment addition postulate. It's just like it sounds. Remember, postulate is just a statement of fact, and segment addition, we're going to look at doing that. I can compare segment lengths. When we compare them, we're going to talk about if they're equal, if the lengths are equal, and therefore the segments are congruent. I can use the definition of midpoint to solve problems. So we're going to see what word goes hand in hand with midpoint. Alright, so we're jumping into our notes now. You want to make sure that you have already checked off your learning objectives for section 1 because now we're looking at section 3. Make sure you have paper ready for notes. If at any time you need to pause and rewind, just make sure you go at a pace that's good for you. So the first thing we're going to look at is the ruler postulate. The ruler postulate says that every point on a line can be paired with a real number. So here we have this line AB. And right below it you can see that we just paired it up with a ruler. Now we can't see exactly what these values are on the ruler, but we can go ahead and say this is coordinate A and here's coordinate B, and it's the coordinate for point A and the coordinate for point B. Notice how they used a lowercase letter to represent it. So the ruler postulate is going to help us to measure lengths of segments using a given unit, and so that way we can find the distance between points on a number line. So for example, it says, what is ST? Now, we do want to kind of talk about how it said this right here, ST, because it's asking for the length, not the segment. So that's something you might want to put down in your notes, that when we talk about the length, we don't use a bar over it. So the length of AB would just be length AB. And if I wanted to talk about the segment AB, well, the segment AB, what am I doing? The segment AB, we would use a segment bar over it. And that's how we can tell the difference. So my question, or in our example, it says, what is ST? And that's talking about the length, because there's not a segment bar or a line over it. So this is pretty easy. I mean, this is on a number line. We see S is at -4, we see T is at 8. We could simply count and see. Or we could do some math here and we could say 8, and we're going to subtract this -4. So 8 minus a -4. Minus a negative is adding. So 8 plus 4, we get 12. So our length of ST is equal to 12. Again, if you wanted to count it, you could just as easily count. So -4 to -2, that's 2. We're going by 2s, 4, 6, 8, 10, 12. So the length is 12. And again, since I'm talking about the length, I'm not going to put a bar over this. So I'm saying the length is equal to 12. Alright, so you try, it says, what are the lengths of SV and the length of UV on the number line above? Go ahead and pause it to give yourself a minute or two to answer this question, and then move on to the next slide. Alright, now we're going to talk about the segment addition postulate. This postulate states that if you have 3 points that are collinear, remember collinear means that they're on the same line. So here's our 3 points, A, B, and C, and those are collinear. And if the point B is between points A and C, as shown, then we know that the length of the segment AB plus the length of the segment BC is equal to the length of the segment AC. And I mean, I don't think that's anything difficult to grasp. Definitely, you see here's this length AB, here's this length BC. If you take them and add them together, you'll get the length of this whole segment AC. So that's what the segment addition postulate says. So let's look at our example down below. It says, if the length of segment EG is 59, so all of this is 59. Let's go ahead and we'll mark that. So we know this whole thing is 59. It says, then what are EF and FG? So it wants us to find the smaller segments. What are the lengths of these smaller segments? Well, since I know that the length of the segment EF is equal to 8x minus 14, and I know that the length of the segment FG is equal to 4x plus 1, then I can say the segment EF plus the segment FG, those lengths, is equal to the segment of EG, the length of that segment. So I'm going to write that out. So I know, I'm going to do it actually all the way up here, I know the length of EF plus the length of FG is equal to the length of EG. And now I'm just going to use some substitution. I'm going to go ahead and substitute in for EF. The length of that is 8x minus 14. The length of FG is 4x plus 1. I'm going to drop this plus sign. And this is equal to EG, the length of EG, which is 59. And now I'm just going to have to use some algebra. So I'm going to combine like terms. 8x, 4x, I'm going to get 12x. Negative 14, positive 1, I get negative 13, equals 59. I'm going to move this negative 13 to the other side by adding it. So I get 12x is equal to 72. And then I'm going to divide by 12 on each side. So x is equal to 6. But all I did here was solve for x. My question wants to find out what are the lengths of these two segments. So now I have to take this 6 and just substitute it in for each of my segment lengths, and I'll get my answers. So substituting in for the length of EF, I have 8 times 6 minus 14. So 8 times 6 is 48. 48 minus 14, we get 34. So the length of EF is equal to 34. To find the length of FG, again, 4x plus 1. I'm going to substitute in the 6. Multiply 4 times 6 and get 24. I'm going to add 1 to it, and I get 25. So the length of segment FG is equal to 25. And I can check to make sure that's right because 34 plus 25 should give me 59, and it does. Alright, so now you try. Here's your problem. Try this one out. Again, pause it, and then when you're ready to move on, join me on the next slide. Alright, so now we're going to look at the equal sign versus the congruent symbol, about when to use which one. So when numerical expressions have the same value, you say that they are equal. 2 equals 2. Similarly, if two segments have the same length, then the segments are congruent segments. So we're never going to say a segment is equal to another segment. We're going to say that the segments are congruent, and we can determine that based on if their lengths are equal. So follow along right here. It says this means that if the length of AB is equal to the length of CD, then the segment AB is congruent to the segment CD. And you could go vice versa. You could say that if the segments are congruent, then the lengths are equal. When we talk about congruency, we use what we call tick marks, or some teachers call them hash marks also. So if I have two segments, we'll just use what they said, A and B, and segment AB and segment CD. And I know that they're congruent because their lengths are equal. then I could show that by putting tick marks on them. If I have multiple things that are congruent and I wanted to differentiate which ones are congruent with which, then I could use one tick mark for one set and then two tick marks for another set and so on. Alright, so on a number line, the coordinates of x, y, z, and w are -7, -3, 1, and 5, respectively. Find the lengths of the two segments, then tell whether they are congruent. So here's our first example. And there's your U-try problem. I'm going to go ahead and draw out this number line, this so-called number line. I need from -7 to 5. So maybe I should make it longer. -7, -6, -5, -4, -3, -2, -1, 0, 1, that's a 0. 1, 2, 3, 4, and 5. Okay. So it says find the lengths of the two segments, then tell whether they are congruent. So let's put these points on here. I know x is at -7. So here's x. Y is at -3. 1 is for z. And w is at 5. Okay, so segment XY, so to find the length of segment XY, I know that the length of XY, if I just use my number line and count, I have 1, 2, 3, 4. So the length of XY is 4. And the length of ZW, again, I can use my number line and just count it out. 1, 2, 3, 4. Nope. The lengths are the same, so I know that yes, these are congruent. Or I could throw in a congruent symbol. Alright, so you try. Determine if segment YZ and segment XW are congruent. Again, pause it if you need to, and then move on to the last slide. Alright, so this last slide talks about midpoint. Now, the midpoint of a segment is a point that divides the segment into two congruent segments. Just like it sounds like. It's the middle. It's the middle point, and that's why it's called the midpoint. Now, a point or a line or a ray or any other segment that intersects the segment at its midpoint, like we see here. So here's the segment. Here is the midpoint, and we know it's the midpoint right here, because it tells us over here, B is the midpoint. Now we have this line that's dividing, that's going through the midpoint. If we have a line or a ray or any other segment that intersects the segment at its midpoint, this is called a bisector. In this case, it's a segment bisector because it's bisecting a segment. And we indicate that it has bisected our segment by using these tick marks to show congruency. Now we know that segment AB is congruent to segment BC. Alright, so example, Q is the midpoint of segment PR. So knowing that Q is the midpoint, because it's stated here, I know that this segment PQ is congruent to this segment QR. And since they're congruent, then I know that the lengths are equal. So my question asks me, what are the lengths of PQ, of QR, and PR? So the first thing I need to do is solve for x, and then I can answer those questions. So I'm going to scroll up, and I'm going to say 6x minus 7 is equal to 5x plus 1. Solving for x, I'm going to subtract the 5x on both sides, so I get x minus 7 is equal to 1. I'm going to add the 7, so x is equal to 8. Now knowing that, I can substitute it in, so 6 times 8 minus 7, I get 48 minus 7, so 41. 5 times 8 plus 1. 5 times 8 is 40, and 40 plus 1 is 41. And it's actually kind of silly that I did that twice because I knew that they were going to be congruent. But I guess I could just say that I was double checking my work. So now I know that the length of PQ is equal to 41. The length of QR is equal to 41. And the length of PR is equal to 41 plus 41, which is 82. Alright, so here's your last U-try. Go ahead, check it out, get it done. Make sure that you have all the notes for this video and that you've tried all of the U-tries. If you have any questions, just make sure you come and ask me in the morning or ask me during class. Alright, thanks y'all.